All right, part two. Now let's do an example. So let me get a new page going here because it, as all of the questions in this class, takes up a lot of paper. So here's our example that we're going to solve first before we write out the generic form of the elimination method. We're just going to solve this system. So here's our two differential equations. X prime is equal to 3x minus 4y plus 1. And then my other equation here, y prime is equal to 4x minus 7y plus 10t. As it is, this is not written in that generic form that we saw in the last video, so let's rearrange this so that it is in that form. So we need to get my x prime and x together, y prime and y together, and then the function or anything that's left over that does not have an x or a y on the right-hand side. So that first equation there, I'll leave the x prime, and I'm going to subtract the 3x over to the left-hand side. I'm also going to add the 4y over to the left-hand side, and just leave the function 1 on the right. There's no y prime here, but that's perfectly fine. It just means that the y prime has a coefficient of 0. The second equation there, I'm going to subtract the 4x over to the left-hand side. We still have that y prime on the left-hand side. I'm going to add the 7y and leave the 10t on the right-hand side. So the reason we're doing that is now we want to rewrite this using those operators. So this first equation up top, we're going to rewrite the first two terms with the x is going to have the operator d minus 3. So that operator acting on x plus. So now my next operator, I know it looks silly, but we're going to leave it as the operator 4 onto the function y. It's the same thing as just 4y. Still equal to 1 on the right-hand side. For my second equation, we're going to write that as the operator negative 4 on x plus the operator d plus 7 on the function y, and that's all equal to 10t. All right, the reason we're writing it like this is now this mimics a system of equations algebraically. So if I want to use the elimination method, I need to multiply either one or both of these equations by something. Then if I add the two equations together, they'll cancel out. So what I'm going to do is I'm going to multiply a positive 4 on equation 1, and I'm going to multiply the operator d minus 3 onto equation 2. All right, so multiplying the first one here by a positive 4, that's going to leave me with 4 times the operator d minus 3, that's acting on x, plus 4 times 4 is 16, acting on operator y, is all equal to 4 on the right-hand side. Equation 2 multiplied by the operator d minus 3 will write out like this. So onto this first term here, we still have the negative 4. Then we'll have the operator d minus 3, that's acting on x, plus we still have the operator d plus 7, but we're also going to have the operator, I have them in the wrong order, sorry. We have d plus 3 that we're multiplying on, and we already had the operator d plus 7 that's acting on y. And this is all going to be the operator d minus 3 acting on the function 10t on the right-hand side. Remember that I was specific here, but we didn't really need to change the order of these two things. But just for future reference, when you're operating on an equation, you always want to apply it to the left. So we have the constant. That's just a constant. It stays out front. And then d minus 3 acting on x. Then we had this. We're going to operate this with d minus... Oh, that's supposed to be a minus 3. Glad I checked. So d minus 3 acting on d plus 7y. And then on the right-hand side, we're still going to have d minus 3 acting on 10t. Okay, so let's simplify this down a little bit. That first equation I'm just going to leave pretty much as is. It's only the second equation that I want to focus on for now. You know what? All we really need to do to simplify this second equation down is just to go ahead and operate what d minus 3 onto 10t is. So operating the d onto 10t is just taking the derivative, so we're going to get 10. Operating the negative 3 onto 10t is just going to multiply it together to give us the negative 30t. I'll just leave it like that. Just ignore this middle part right here. Then we're going to add the two functions together. The reason we are adding these two functions together is now this first term, 4d minus 3 operating on x, and then this first term, negative 4d minus 3 acting on x, is going to cancel each other out. So we're going to add the two equations together. All right, the x's have now canceled. We're going to end up with the 16y from the first equation added onto the operator d minus 3 operating on d plus 7 onto the function y. On the right-hand side, we're going to have that 4 coming down, added onto what we already had from the second equation, 10 minus 30t. All right, and then simplifying this down a little bit, we still have the 16y out in front. We can go ahead and multiply these two operators together using the same method that we were doing in the other example in the last video. So these will multiply together to be d squared plus 4d minus 21. That's still operating on y. The right-hand side, we can just combine some like terms together. So 14 minus 30t. All right, now what we can do is we can actually combine these two terms together if we think about them like operators. So we have 16 acting on y, and then we have this operator acting on y. But remember, this negative 21 acting on y is just negative 21y. So we have positive 16y and negative 21y that we can combine together. So we can rewrite this left-hand side as the operator d squared plus 4d minus 5 times y. And that's still equal to 14 minus 30t on the right-hand side. Okay, and this is now something that we solved back in chapter 4. If you were to actually do the operation on y, it would be the second derivative of y plus 4 times the first derivative of y minus 5y is equal to this stuff on the right-hand side. So we're just going to have to solve this like we did in chapter 4, which unfortunately, because there is a function on the other side, we're going to have to use the undetermined coefficients method. So I'm just going to do it real quick here. So first thing we need to do is we need to find the homogeneous solution. Remember, to find the homogeneous solution, this is where we look at the auxiliary equation. So the auxiliary equation for us is going to be r squared plus 4r minus 5 is equal to 0. This should be easy to see that you have two solutions, negative 5 and positive 1 coming out of that, which means that we have the homogeneous solution, c1e to the negative 5t plus c2e to the t. Okay, then we're going to have our undetermined coefficients. This is to find the particular equation for the right-hand side. So we're going to try something in the same form. This is just a polynomial out in front. There are no e's, there are no cosines, and it's a linear polynomial. So remember, whenever you have a polynomial on the other side, and the roots don't match, which of course they can't here because there's no e's or anything like that, just try your own polynomial, but with generic coefficients. So it's a linear polynomial. We're going to try a linear polynomial. We're going to have to take the derivative twice and plug it in. So the first derivative is just going to give me a. Second derivative is just going to be 0. If I plug this into here, we're taking the second derivative of y, which is 0, plus 4 times the first derivative of y, which is a, minus 5 times y itself, which is this at plus b. And that's equal to the other side of the equation, 14 minus 30t. So again, that's just taking the function itself, the derivative, and the second derivative from what we're trying, our particular solution, and plugging it into this differential equation here, written as operators, which is still the same thing. Okay, now just solving this for the a and the b, I'm going to dot this. It's not hard to do this, but you end up that a is equal to 6 and b is equal to 2. Okay, so that means that our full solution, y of t, is just going to be adding the homogeneous solution with this new particular solution that we just found. So all in all, we're going to have that c1 e to the negative 5t plus c2 e to the t, this is coming from the homogeneous solution, plus our particular solution with a and b plugged in, so 6t plus 2. This is now my y function. Going back to the original, the original question up here, y is equal to this stuff solves this. We're only missing the x sub t. So just to write out down here, now we need to find x of t. This isn't nearly as bad, and there's actually two different ways of doing it, and you can do it however you want. So I'll just write out both different ways. To find x of t, one thing that you could do is start over and use the elimination method again to isolate, oh, spelled it right, the x of t. So when we first did it up top here, we isolated the y of t, but you could just rechange what you're multiplying to isolate the x of t. So if you like doing that, then great, do that. Let's look at method 2, which I think is simpler. So method 2 is that you want to get an equation for x of t in terms of the y and the y prime. So looking back at our original equations up here, if you can somehow get x in terms of y and y prime, then do that. And we can do that easily just from our second equation here. I'm going to have to go down to a new page. So what we're going to do is we're going to have x of t, oh, don't capitalize it, x of t, we're going to set equal to 1/4 y prime plus 7/4 y minus 5/2 t. And I know it looks like I'm getting that out of nowhere. This is just solving my second equation for x. So get the 4x on one side by itself and then dividing everything by 4. So solving the second equation for x, so that way it's in terms of y's and y primes, we get this. Then all we need to do is substitute the y that we found earlier into that. To do that, we are going to have to figure out the derivative of y. So let me just copy down what y was equal to from up here. Right, y was this. And then we're going to need the derivative of this, so we can plug it into the equation just up top here. So the derivative, negative 5 c1 e to the negative 5t plus c2 e to the t plus 6. Okay, now substituting that into this equation up here, I get x of t is equal to 1/4 times the derivative. It's too much to write out. I should have just copied, but it's too late now. I'm so far into it. Okay, so that's 1/4 times the derivative plus 7/4 times the function itself. Just copied it there. Oh, no, it didn't. There it goes. And then minus 5/2 t. And then you would then simplify this down. I'm going to dot this as well. So just combining like terms together, we end up with this. X of t is equal to 1/2 c1 e to the negative 5t plus 2 c2 e to the t plus 8t minus 5. Oh, sorry, 8t plus 5. All right, I know it's a long process, but that's just how everything is in this class. So just to go through it real quickly again, you're given this system of differential equations. Rewrite it into the general form and change it into operators. Use the elimination method, multiplying the first equation by something, the second equation by something, and then adding the two equations together. We did that to cancel out the x. Now we have a differential equation that only has y's in it, and it turned out to be a second order differential equation. That means we had to use some chapter 4 stuff to solve it. So we solved and we got y of t here. Now that we have y of t, we can go back and find x of t by isolating x in terms of y, and then just substituting in the function y. Okay, I didn't have time to do the generic elimination method. I'm going to do that in the next video, and then we'll do one more example of using this elimination process.